Solving a rational inequality is going to be similar to solving a polynomial inequality, but there's a little difference. You need to rewrite this so that one side of the inequality is 0. So rewriting this, we'll have to subtract 2, so we'll have x plus 1 over x plus 3 minus 2 is now greater than or equal to 0. We're going to have to subtract these two expressions, so we need a common denominator, which is x plus 3. So rewriting, we'll have x plus 1 over x plus 3 minus 2 times x plus 3 over x plus 3. We need our common denominator. This is now greater than or equal to 0. So combining the numerator, we'll have x plus 1 minus 2 times x plus 3 all over x plus 3 greater than or equal to 0. We now have, distributing the negative 2, x plus 1 minus 2x minus 6 all over x plus 3 greater than or equal to 0. Now combining like terms, we end up with negative x minus 5 over x plus 3 is greater than or equal to 0. Now, what's a little bit different here is we need to set the numerator equal to 0 and the denominator equal to 0 to find our boundary points. So here we'll have negative x minus 5 equals 0, x plus 3 equals 0. So here we'll have negative x equals 5, and then x equals negative 5. Here, subtracting 3, we'll have x equals negative 3. So when the numerator is 0, that's where the expression is 0, and when the denominator is equal to 0, that's where the expression is undefined. So these two boundary points we're going to place on our number line. So at negative 5, that is where the expression is equal to 0. And when x is negative 3, that's where the expression is undefined. So I'm going to put a U there for undefined. So we see that these boundary points have divided our number line into 3 intervals. We need to find out what is the sign of our rational expression in between those boundary points. So let's pick some numbers. Pick a number smaller than negative 5. I'm going to pick negative 6. You can pick any number smaller than negative 5. A number between negative 3 and negative 5, well, there's only one integer, so let's pick that, negative 4. And then a number larger than negative 3, let's pick 0. 0 is always a good number to work with if you can. So again, each of these test points need to be substituted back into our expression. So let's take the negative 6 and substitute negative 6 into our x's. So here you'll have negative of a negative 6 gives us positive 6. So 6 minus 5 is positive. Negative 6 plus 3 is negative. So positive divided by a negative is negative. Remember, you're only interested in the sign. All right, let's do the same thing with negative 4. So replacing negative 4 with our x. So the opposite of negative 4 is 4. 4 minus 5 is negative. Negative 4 plus 3 is negative. Negative divided by negative gives us a positive sign. And now we're going to have to do the same thing with the negative, with the 0. So let's substitute 0 here. So 0 minus 5 is negative. 0 plus 3 is positive, so we end up with negative divided by a positive is negative. So we're looking for where this expression is positive. So our interval notation will be negative 5 to negative 3, but the negative 3 is not included. Our set builder, all x, such that x is greater than or equal to negative 5, but less than negative 3.